This video will show you how to integrate core image filters and machine learning filters into an iOS video calling app or video conferencing app using the Stream SwiftUI SDK. We will begin by adding standard core image filters like sepia, bloom, and blur. Then I'll show you how to add machine learning based face filter similar to snapshot lenses using the Apple's Vision framework. To follow along with this tutorial, you will need a stream video calling or live streaming app built with iOS SwiftUI. Once you have a video calling or live streaming app built with Stream, you can easily integrate the core image filters or machine learning filters. If you are new to the Stream Video SDK for iOS, you can visit our website and go to Developers and select the option Video and Audio. Under SDKs, you select iOS. On this page, you will find different tutorials such as video calling, audio rooms, and live streaming. There is also another one for voice assistant. So I encourage you to check this page to learn more about the key features and UI components of the SwiftUI Video SDK and get started. To run the sample apps in this tutorial, you will need some credentials. So by visiting the Stream homepage, you should go to the top right and click the button Start Coding Free to sign up for a new Stream account to obtain credentials to run the app. If you are building a production app, once you have an account, you can also use your dashboard's API key to generate a token for the app. This can be done using our token generator service. If you are building a production app, you can also generate the token using your server-side implementation. Let's look at the underlying technologies that will be covered in this tutorial. Filters can be integrated into video applications in many ways, such as using machine learning algorithms to place objects on users' body in real time. The Vision framework on iOS and other Apple platforms can achieve the above. Using the core image framework, you can also apply basic filters, that is non-AI based filters, to video frames. Apple also has a framework called Video Toolbox that can be used for advanced compression and decompression of video effects. In summary, to add video filters to your iOS app, there are three core technologies you can use. Core image, that allows developers to use built-in and custom filters to process photos and video images. You can learn more about core image filters from the filter catalog docs. Next, we have the Vision framework. The Vision framework uses Swift concurrency and machine learning to filter input images and videos. Finally, we have Video Toolbox, a low-level framework from Apple that provides developers direct access to hardware encoders and decoders for video compression and decompression. Let's start by adding standard video image filters to a SwiftUI app. I have already created a new SwiftUI project. Let's start the project with two configurations. First, we need to set privacy for camera usage and microphone usage since we are creating a video calling app using the Stream's iOS SDK. So I'll select the root folder and go to the Info tab and hover any of the key items here and click the plus button to add a new privacy. I'll go to the section Privacies and select Microphone Usage Description. For the value field, let's put, for example, Video Filter Sample would like to use your microphone. I will copy the text and press the return key to save it. Then I'll click the plus button again and add another privacy for camera. Then let's paste the text and change microphone to camera. Next, we will install the SwiftUI Video SDK. You can find it from this GitHub repository. There is a link in the description of the video. So let's go to the Xcode project and select File, Add Package Dependencies, and paste the URL here. So that has pulled the repo I showed previously. Let's add the package. Since we have a SwiftUI app, we don't need a UIKit version of the SDK. So let's select this option and set it to none. So we now have Stream Video, that is the core video SDK, and Stream Video SwiftUI, consisting of reusable SwiftUI components for building video calling and live streaming applications. So I'll add the package. Under package dependencies, you have noticed we now have three items. Stream Video, that is the core video SDK. If I expand it, it contains all these files and folders. Then we have Stream WebRTC that helps to establish a call, and Swift Protobuf that is responsible for data serialization. We have now fetched and installed the video SDK and also set privacies for microphone and camera usage. Next, we want to add standard video image filters. The StreamSwift SDK supports all built-in core image filters. So once you add the SDK to your SwiftUI app, you can access the standard filters and implement custom ones as well. For the sample app in this section, we will integrate bloom, blur, and sepia filters into the stream video app we just configured in Xcode. What we have to do next is to configure the SwiftUI app to display videos from local and remote participants. So let's go to the project navigator and add a new file. I'll select the option New File from Template and leave the user interface as a SwiftUI view and click Next. I will name the file Participants View and create it. The purpose of this file is to display both local and remote participants of the video calling application. We don't need a preview, so I will delete it. Under the import section, I will import stream video and stream video SwiftUI. Stream video is the core video SDK, and stream video SwiftUI consists of reusable SwiftUI components for building video conferencing applications or live streaming applications. In the participants view struct, I will define the following properties: one for call, participants, and on-chain track visibility. Next, in the body of some view, let's remove the text and add a geometry reader consisting of a lazy V-stack that displays the participants in a scroll view. We have an error because make call participant view is mixing. So let's add it over here. I'll add a view builder and add this function make call participant view consisting of video call participant view with all these properties. So this file configures both the local and remote participants and display them on one screen. We will also need another file to display the local participant. So I'll go to the project navigator again and add a new file in the same way we did previously. I will call it floating participant view and create it. Like the previous file, I will add the imports for stream video and stream video SwiftUI. Then I'll add the following properties in the floating participant view struct. In the body of some view, we will add the floating participant configuration. If we have a participant in a call, we use the SDK's video renderer view to display the local participant. The SDK's video renderer view gives you a complete video calling UI for your app. So once you use that, you get call controls and other UI elements for managing calls. You can learn more about it by visiting our documentation. There is a link in the description of the video. So the floating participant view is just a rectangular view with corner radius. It displays in a similar way like the picture-in-picture feature in FaceTime calls. So for this example, we also don't need a preview. So let's delete that. We now have the local participant view and also another view for displaying both local and remote participants. Next, let's add another file called filter service. In this file, we should define all the types of filters we want the app to support. There will be only 3 built-in core image filters: bloom, blur, and sepia. However, you can also implement as many filters you want or create custom ones. So at the import section, we will add the following imports. Then we need to define each of the filters. First, I will add the sepia filter. In the same format, I will add the bloom filter. And finally, the blur filter. Let's replace this struct with a filter service class that conforms to observable object. So in this class, we define these 2 properties and also initialize it with the filters we defined previously. By default, the video SDK displays call controls at the bottom part of the screen. Since our use case focuses on video filters and not a full video calling, we can override the UI and add a filter menu to the call controls area to show and hide the supported filters we just added: bloom, sepia, and blur. Let's add another file called filter menu. So we'll use this file to override the default call controls of the app. So I will add these properties here. In the body of some view, let's embed this in a V-stack. Then I will replace the text with an H-stack consisting of a button and label. When the filter menu is not expanded, we will show this camera icon. And once a user taps on that, we expand the menu to display the 3 filters. In the V-stack, Let's add another code snippet to display the filters. So once we tap the filter menu button we defined here, we will display all the supported filters. We still have some errors because we haven't added the imports. So let's add stream video and stream video SwiftUI and also remove the preview. So the filter menu expands and collapses with a bouncy spring animation. When expanded, it reveals a horizontal stack containing all the 3 supported filters. The last thing we need to do is to display the filter menu on the active video call screen. To do that, we should wrap it in the call controls area in another file. So let's add a new file here and call it custom video view factory. I will then replace its content with the following. So in this file, we create a video view factory class that conforms to the SDK's view factory, which allows you to do UI swapping and advanced customization. So in this class, we add this function to override the default call controls from the SDK. Our last configuration to perform to see the filters implemented is registering the view factory class at the entry point of the app. Just like the previous files, I will add these imports and also define the following properties here. We define a view model and create a new stream video client, API key, token, user ID, and call ID. For testing, you can copy the credentials of the video calling tutorial on our website and use them for all these placeholders. You can find a link to the tutorial in the description of the video. So you grab the credentials and replace the API key, token, user ID, and call ID. You can also use our token generator service, which I showed in the beginning of the video, along with the API key from your stream's dashboard. So this requires a user ID and API secret, so you can get this value from your dashboard. All the links can be found in the description of the video. Next, I will add an init function and create a new user with user ID, name, and avatar. Then we initialize stream video with the API key, user, and token, and also an optional configuration that allows you to show the video filters. Lastly, in window group, let's replace content view with this code snippet. So when there is a call, we display the call container with our filters implementation. Otherwise, we show a loading screen. And once the app appears, we create and join a call with the call type default and using the specified call ID. The call type default is used for standard video calling. If I put a period here, you have noticed we also have some other call types like live stream, development, and audio room. You can also create a custom call type from your stream's dashboard. So this is all we need to set up the standard core image filters with stream video SwiftUI. Before running the app, I'll grab the credentials from the video calling tutorial on our website to fill all these placeholders. Since we need a video to show on an iOS device, I'll change the simulator and select Amos iPhone and run the app. So when you run it, you should see the integration of the core image built-in filters with stream video SwiftUI. You should now be able to apply bloom, blur, and sepia filters to your video frame. In the next session, I want to show you how to add an ML filter to stream video SwiftUI. By supporting AI filters in your app, you can offer users more fun ways to enhance their video during VoIP calls and live streaming. The iOS 26 app example in this section puts an object in the call participant's face using an ML filter. So the object follows the direction and position of your face as you move the head in different directions. For simplicity and demonstration, the example in this section uses a logo as the object that moves towards the face's location on the device's screen. You can also modify the ML filter and apply it as digital eyeglasses or a mustache for a real-world use case. To apply the machine learning-based face filter to stream video, you can use the following steps. First, you should find a face within a video image and convert the CIImage to UI image with helper functions. Then you add a custom AI video filter. And finally, register the custom AI video filter in your filter service class, similar to how we implemented the standard built-in filters. To try the demo app in this section, you should clone and run the Xcode project from this GitHub repo. So let's look at how you can implement a machine learning filter in your stream video SwiftUI app. This code snippet uses the Apple's Vision framework to detect faces in video images and apply ML filters to the video. So first, you should send a request to find faces within a video image using vn-detect face rectangles request. In return, the body or face detection request will display faces as rectangular bounding boxes with origin and size. After detecting a face, what you need to do next is to convert the CIImage to UIImage. Then you add the ability to draw on it using this helper function. The image conversion must be done because CIImage cannot hold and manage the actual pixel data of an image in your app. The third step is similar to how we implemented the standard built-in filters, so you can add an ML filter to your app using the SDK's video filter. For more information about the video filter, you can visit our documentation. Its link can be found in the description of the video. So once you detect a face in a video image and convert the CIImage to UIImage, and finally add the ML filter using the SDK's video filter, the last configuration you need to do is to register the filter in your filter service, similar to how we did it previously. So we define that with this code snippet. With the sample app for this section, we have sepia and the ML filter. When you clone and run the sample demo for this section from GitHub, it will display a video conferencing UI similar to this one. As you move your head to a different location, the ML filter, that is the logo, will move along with the face's direction and position. In addition to adding these video image effects and AI filters to your Stream Video iOS app, you can also integrate video calling filters like noise cancellation, voice cloning, and swapping. You can read more about audio filters in our video documentation. You will find a link in the description of the video. That is everything we have in this video. I showed you how to enhance an iOS video conferencing app using machine learning based filters and standard core image filters. You can apply the same filters to a live streaming app created using the Stream SwiftUI SDK. The built-in bloom, blur, and sepia filter sample app can be found on GitHub. You can also find the machine learning based face filter sample app on GitHub. I encourage you to grab each of the SwiftUI sample projects and try the filters yourself.